Hello friends, today's question. Blocks A and B each have same mass m 1 kg. Determine the largest horizontal force P which can be applied to B so that A will not slip upon B. Neglect any friction. So we have two blocks A and B, and the angle of inclination is given 37. A force P is being applied on it. Okay. So first of all, let's draw the free body diagram for the individual blocks and with solve them for the all the relative forces which will be acting. You can say for block A, and we also assume that both the blocks are moving towards left with the acceleration of A. Okay. So here there will be a MEG in the downward direction. Okay. And because of the contact between A and B, there will be a normal force. Let us call that as NA. And this normal force can be divided into two components. So this will be over angle theta, where it is 37. So we can say this will be over NA sine of theta, and this will be NA cos of theta, and it is moving towards left with the acceleration A. So let us resolve the forces, write the equation rather for all these resolved forces. You can say for vertical direction, we are going to have, as there is no motion in the vertical direction, their summation will be equal to 0. So we can say that our NA cos and MA G. Okay. So we have MAG minus NA cos of theta is equal to 0. From here we can write the equation for our normal NA, which will be equal to MAG divided by cos of theta. Now let us write the equation for the horizontal direction. We are going to get NA sine theta is equal to MA and its acceleration. From here we can also write equation for normal, which is equal to MA divided by sine of theta. Equation 1 and equation 2. So equating 1 and 2, you can say from equation 1 and 2 we get MAG cos of theta will be equal to MAA divided by sine of theta. Here mass cancels out, okay, and we can write this as, we get this as A will be equal to G sine of theta divided by cos of theta, or we can say A is equal to G tan of theta. Now let us consider block B. So you can say for block B, force P is being applied on it, and let us, this is our block B, downward direction, there will be MBG, here will be normal because of the surface, that is MB, and also the normal, that is NA. So once again we are going to resolve it in 2. So this will be over theta. So we get this as NA cos of theta, and this will be NA sin of theta, moving towards left with the acceleration A. So once again let us resolve the forces. Okay. So we can say for horizontal, direction, we can say P minus NA sin of theta is equal to MB multiplied by A. Now we already know the value of NA as well as acceleration A. Okay. So we can modify this equation as, we can write, but NA is equal to MAG cos of theta, and A is equal to G tangent of theta. Therefore P minus, MAG divided by cos of theta multiplied by sin of theta is equal to MB G tangent of theta. So this also become P minus MAG tan of theta is equal to MBG tangent of theta. You can say that P is equal to G tan of theta MA plus MB, and it is given that both mass are same, that is our 1 kg. We substitute the values, get Pg is our 10, we get tangent of 37, 1 plus 1. So from here we get the value of P as 15 Newton. So for this value of force, of P, that is applied on block B, block A will not slip on block B. Block A will not slip on block B. So this completes the question. Thank you.